Section 11.11 Thermodynamics of batteries and fuel cells. Electrochemical cells, batteries, fuel cells, they are the same thing. They convert the Gibbs free energy of chemicals to electric work. And I want to remind you, this delta G of reaction is always less than or equal to the electric work for any electrochemical cell, battery, or fuel cell. This is the Clausius inequality. So again, in this Clausius inequality, we have learned that the entropy change is greater than or equal to dq over T. When does this equal sign hold over here? For reversible processes, delta G of R is equal to electricity. For irreversible processes, delta G of R is always less than this electric work. So when a battery, fuel cell, or electrochemical cell does work, we have this equation. Because delta G of R is negative, this work electric work is also negative. And then if we look at this equation, delta G of R is more negative. Therefore, the absolute value of this delta G of R is greater than the absolute value of this electric work. Again, both are negative. This is more negative. That means if you have a battery and the Gibbs energy of the battery decreases by 1 joule, the cell can do only less than 1 joule electric work in an irreversible process. The cell can fully utilize this 1 joule Gibbs energy change in a reversible process. Now let's say we have a rechargeable battery, and if we try to recharge the battery, alright, and then in this case, this delta G of R is positive. The Gibbs energy of the chemicals in the battery increases. And this electric work is positive because electric work is done to the system. In this case, this delta G of R is positive, and this electric work is positive, so we can say the amount of electric work is of course greater than or equal to the amount of the increase of the Gibbs energy of the cell. And when does this equal sign hold? Simple. In a reversible process, the electric work is equal to the Gibbs energy of the reaction. In irreversible processes, this W electric is greater than the Gibbs energy change of the reaction. So you need to provide more than 1 joule electricity to increase the Gibbs energy of the chemical cell by 1 joule in an irreversible process. And in the end, actually this section is about the second law of thermodynamics. In an irreversible process, we have the amount of the decrease of the Gibbs energy greater than the amount of the electricity. So some Gibbs energy is wasted, and during this process, you increase the entropy of the universe. Now let's charge the battery. When you charge the battery, you need more electricity than the amount of increase of the Gibbs energy. Again, some energy is wasted in the form of heat that will also increase the entropy of the universe. So in short, the entropy of the universe always increases, with 2 exceptions. One, heat death. If the universe has reached thermal equilibrium, there's no more change. 2, if all processes in this universe are reversible processes, and then there's no entropy change.